You know that low, four-note coo, the one that sounds a little sad, drifting in over the fence before your alarm even goes off? You've heard it so many mornings, you've probably stopped hearing it at all. It's just part of the background now, like a neighbor's air conditioner kicking on. Here's the part you definitely haven't heard. The pair making that sound are, right now, building something inside their own bodies. It has nothing to do with seeds. It has nothing to do with insects. And if you're picturing a mammal when you hear the word milk, that's not what this is. And here's the actual puzzle. Both of them are doing it. Not just the mother, the father too. So how does that work? How does a bird, any bird, let alone the most overlooked one in your yard, end up making milk? And how does it end up making it from a part of its body that, on every other bird, is basically just a waiting room? Let's go find out, because the answer is sitting in plain sight, right behind that beak, in a part of the bird most people couldn't even point to. Start with the room where it happens, just below a dove's throat. Before the food even reaches anything you'd call a stomach, there's a stretchy little pouch called the crop. On most birds, this thing barely gets a mention. A robin's crop, a sparrow's crop, they're holding areas. Food comes in, sits for a bit, moves on to get digested properly. It's the avian equivalent of a mudroom. You don't live there. You just pass through on your way to somewhere else. In doves and pigeons, that mudroom has a second job, and for the first few days of a chick's life, that second job becomes the only job. Here's where it gets strange. According to research from Gillespie and colleagues, under the right conditions, the inner lining of that crop starts to thicken up. The wall of the room itself starts to change. The cells on the surface multiply fast. They fill up with fat and protein, and then they do something cells in most organs never do on purpose. They slough off. They detach from the wall in sheets. The parent is, essentially, shedding pieces of the inside of its own throat. What comes off looks like a soft, curd-like paste. People who've examined it up close compare it to cottage cheese. That paste is the milk, not a gland secretion squeezed out from somewhere off to the side. Actual lining, actual tissue, peeling away and getting handed straight to the chick. And it's not a light snack to tide the kid over until real food shows up. According to that same research, published in PLOS One, this stuff comes in at roughly 60% protein and somewhere around a third fat. Denser in protein and fat than cow's milk. Denser than human milk. For a chick that hatched essentially helpless, this is the entire starter kit. No feathers worth mentioning. Eyes barely open. Not much going on yet. Everything it needs to go from barely formed to recognizably a bird in about 2 weeks comes through this one channel first. No bugs, no worms, no foraging trip required. Just whatever's sloughing off the inside of mom or dad's throat that morning. So that's the what. A pouch behind the throat that, on this bird, moonlights as something closer to a nursery pantry. A wall that grows, then sheds itself, then gets passed along. Now, the actual question we opened with, why does this happen in both parents? This is where the story connects to something you already know, just from a completely different branch of the animal world. According to a study by Horseman and Bunton from 1995, the whole process gets switched on by a hormone called prolactin. If that name sounds familiar, it's because it's the same hormone responsible for milk production in mammals, including humans. Two groups of animals split apart on the evolutionary tree a very, very long time ago, and yet both of them ended up reaching for the same chemical messenger to do the same job. Build food inside your own body for something that can't feed itself yet. And prolactin doesn't check the paperwork on who's mom and who's dad. In a dove pair, both birds' hormone levels respond to incubation the same way. Both crops thicken on the same schedule. Both linings start producing on cue. So when the eggs hatch, there isn't the female has milk, the male brings groceries, division of labor happening. Both parents can step up to the nest and deliver the exact same substance, made the exact same way, because both of their bodies got the exact same hormonal memo. Two-income household, right down to the biology. He takes a shift, she takes a shift, and the pantry runs the same either way. Now, and you might already be wondering this, couldn't you just make this stuff? Mix up something with the right protein to fat ratio. Skip the whole shedding your own throat lining routine and bottle feed that to a chick instead? Researchers actually tried something close to this. According to that same Gillespie research, chicks were given a nutritionally matched stand-in for crop milk. Same protein, same fat. On paper, a dead ringer, but they didn't do well. Some failed to thrive. Whatever's actually happening in that curd-like paste, It isn't just a number on a nutrition label. It isn't something you can hit from a different direction. The chick isn't only getting fed, it's getting something from its parent's own tissue that a spreadsheet can't fake. Which brings us back to that first feeding, the one happening in nests all over your neighborhood right now. A newly hatched dove chick can't manage seeds. It doesn't have the equipment for that yet, and won't for days. So instead, it does something that looks almost alarming if you've never seen it. It reaches up and pushes its head into the parent's open throat, right down to where that lining has just sloughed loose, and feeds directly from the source. The parent's body pumps gently to help it along. For about the first 3 days, this is the entire menu, full stop. Then, gradually, the ratio starts to shift. A little more cracked seed gets mixed in with each feeding, day after day, until by around 2 weeks old, the chick is basically eating what the adults eat and ready to leave the nest behind. 3 days of homemade baby food, manufactured fresh inside the body of whichever parent happens to be on shift that morning. And 2 weeks later, the chick is gone. The nest, which, let's be honest, always looks like a fixer-upper that somehow passes inspection, is empty. And here's the part that ties the whole thing together. Most backyard songbirds are locked to the insect calendar. No bug season, no protein, no feeding chicks. That's the rhythm that limits how many times a robin or a sparrow can nest in a year. Doves quietly sidestepped that entire constraint. When your body can manufacture a high-protein baby food internally, on demand, you're not waiting on anything outside your own front door. According to the Audubon Field Guide, a mourning dove pair can raise 5, sometimes 6 broods in a single season, more than any other native bird in North America. They barely get an empty nest before the next 2 eggs show up. So the next time that 4-note coo drifts in before your alarm, you'll know exactly what's going on behind it. Somewhere nearby, a crop is thickening. A lining is about to give itself up, a little at a time, to something that hasn't opened its eyes yet. Tonight, go take a look at the pair on your wire, your gutter, your ledge, wherever they've decided to set up shop. See if you can spot the nest. And if you do, take a guess for me. Is this their first brood of the year? Or are they already several rounds in? Given what we now know about how that milk actually gets made, I'd bet on several.